Welcome students. In the previous lecture, we have studied about electrical charges, properties of electrical charges and conductors and insulators. Today in this lecture, we are going to study about the Coulomb's law. Coulomb's has given one law which is used to measure the force between the two electrical charges. According to Coulomb's law, the force between the two electric charges is directly proportional to the product of given charges. So let us consider 2 point charges Q1 and Q2. The product of these two charges Q1 multiplied by Q2 is directly proportional to the force, and the force is inversely proportional to the square of the distance between the two charges. So if you have two charges, point charges, one is Q1 and second point charge, another is Q2, and the distance between these two point charges is small r. There will be a force on these two charges. We will consider both charges as positive charge. Q1 is also positive and Q2 is also positive. We know that the charges which are of same polarity, they always repel each other, and charges of opposite polarity attract each other. So here force on Q2 due to Q1 will be in this direction. It will repel, it will be away. So this will be the force on charge 1 because of charge 2. And similarly, this charge will experience a force due to charge Q2 away from Q1. So this will be the force on charge 2 because of charge 1. Both of these forces will be equal, but they are in opposite direction. We can see F12 is in the right direction, F21 is in the left direction. The magnitude of these forces, equal forces, will be directly proportional to the product of both charge and inversely proportional to the square of distance between the two charges. So if you combine these two relations, we will get F is equal to K times Q1 multiplied by Q2 divided by R square, where K is constant of proportionality. K is constant of proportionality. The value of K is 1 upon 4 pi epsilon naught. As we know, epsilon naught is the permittivity of free space. Permittivity of free space, and the value of epsilon naught is 8.854 into 10 raised to the power minus 12 Coulomb square per Newton meter square. This is the unit of epsilon naught. So I will repeat the same thing. Coulomb's law. Coulomb has given a law to measure the force between the two electric charges. We know that if the charges are of same polarity, let us say both are positive charge, they will repel each other. The Q1 will experience a force due to Q2, F21, let us say F21, force on charge 2 due to charge 1. This will be away from Q1. Similarly, Q2 will experience force F12, that is force on charge 1 due to charge 2, away from Q2. They will repel each other. These two forces will be equal in magnitude. The magnitude of the force will be directly proportional to product of two charges, Q1, Q2, Q1 multiplied by Q2. And force is inversely proportional to R square. That is F proportional to 1 upon R square. Combining these two relations, we can write F is equal to K times K multiplied by Q1, Q2 upon R square. K is constant of proportionality. K is equal to 1 upon 4 pi epsilon naught. The value of K, you can write here, the value of K, when you will put the value of epsilon naught in this expression, you will get K 9 into 10 raised to the power 9. So this is an important constant in electrostatics. You must remember, you must by heart this value of K, 9 into 10 raised to the power 9 for free space. Now let us define Coulomb's law in vector form. Suppose there are two charges. First one is Q1, positive charge. Another is Q2. This is also positive charge. And suppose this is the origin. This is origin. You can write here origin. Let us say the line joining origin and charge Q1, there is a vector from origin to Q1. This is, let us say, R1. This is the position vector. This is the position vector of Q1. Similarly, the position vector is R2 from origin to Q2. If we know R1 and R2, we can easily find out the vector R21. The vector between 1 and 2 will be R21. So this is vector towards 2 from 1. I think it's clear from the diagram. This is the position vector of Q1. This is the position vector of Q2. So the position vector between Q1 and Q2 will be R21. Here R21 is equal to R2 minus R1. So the vector from Q1 to Q2, this direction will be equal to position vector of R2 minus position vector of R1. Now we will see how to find the relation, the expression of Coulomb's force between these two charges. We want to find out the force in vector form. So let us start from force on 1 due to 2. So force on 1 will be in this direction. This will be force on charge 1 due to 2. I can write here in vector form force on charge 1. Let us say it is K constant Q1 multiplied by Q2 What will be the distance between these two? This is the position vector r21. Okay, so this is the distance between these two charges. So I can write here r magnitude of r21 square. So whatever magnitude of this vector is, that will be the distance between these two charges. This expression is now for magnitude. Now we will add one more term which will just represent the direction of this force. The direction of this force is towards left. So it is opposite to position vector r21. Okay, so I can write this as minus sign because it is in left direction, and this direction will be a unit vector r21. This is unit vector. Unit vector you can calculate, you know the relation. Unit vector r21 is given by vector r21 divided by magnitude of r21. Similarly, the force on charge 2 due to 1 will be given by k times q1 q2 divided by the square of the distance between two charges. The distance between two charges is r21. Square of r21, and the direction is towards right. This will be the force on 1 due to charge 2. So this is positive sign because it is towards right, and the direction will be shown by unit vector in the same direction. So this is how we can write the formula for Coulomb's force between the two electric charges in vector form. Please note it down, both the formulas. Minus sign here represents the direction of force is towards left, and plus sign represents the direction of force is towards right. Unit vector r21 is vector towards 2 from 1. So it is in the direction towards 2 from 1. So it is towards 2 from 1. You can write here vector towards q2 from q1, and this is unit vector. This is basically distance vector, distance between q1 and q2, distance vector towards q2 from q1. This is unit vector towards q2 from q1. Using the same type of analysis, we can find out the formula for multiple charges as well. We can use simple vector analysis to find out the force on a particular given charge due to multiple charges. Now see force between multiple charges. Using similar type of vector analysis, we can calculate the force between the multiple charges. In this figure, we can see there are 4 point charges q1, q2, q3, q4. And we have a test charge, you can say another charge q5, where we will try to calculate the net force due to q1, q2, q3, q4. So the problem here is the charge q5 will experience some force due to charge q1, some force due to charge q2, some force due to charge q3, some force due to charge q4. Now we will use Coulomb's law formula, and we will try to find out the net force on charge Q5 due to system of multiple charges, from Q1 to Q4. One by one, we will see the force experienced by Q5. Start from Q1. Q1 will repel Q5 in this direction. So the force on Q5 due to Q1 will be in this direction, towards right. So let us say it is F51. Force on charge 5 due to charge 1. Similarly, Q2 will repel Q5 in this direction. So let us say the force is F52. Force on charge 5 due to charge 2. The resultant of F51 and F52 is R1. Using law of parallelogram, we can find the direction of resultant of F51 and F52. Now come to charge 3, Q3. Q3 will repel Q5 in this direction, away from Q5. So the force will be away from Q5. This, let us say the force is F53. So F53 is force on 5, charge number 5 due to charge number 3, F53, away from Q5. Now see charge number 4. Before coming to charge number 4, just try to find out the resultant of F53 and R1. Complete the parallelogram. Just look at F53 and look at R1. This is the R1. And complete the parallelogram. This is the parallelogram. This is the parallelogram. So the resultant is R2. Now come to charge number 4. Charge number 4, Q4 will repel Q5 in this direction. So the force on 5, charge number 5 due to charge number 4 will be upwards. Now find out the resultant of F54 and the previous resultant R2. Complete the parallelogram. Complete this parallelogram and draw the resultant. This resultant of F54 and R2 will give you the net force on Q5 due to Q1, Q2, Q3, Q4. So individually, first you find the force due to individual charges. Due to Q1, due to Q2, then resultant, then from Q3 to Q5, then again resultant, then from Q4 to Q5, and then the final resultant, F net. So this is how, using the vectors, we can calculate the net force on a given test charge. Let us say this is test charge Q5. So we can calculate the net force on Q5 due to 4 different charges, Q1, Q2, Q3, Q4. Draw this diagram and try to understand how we draw the vectors to represent the forces experienced by Q5 due to each individual charge, and then find the net resultant, F net. Similarly, suppose there are n number of charges and you want to find out the net force experienced by a test charge which is placed in the near to this system of charges. N number of charges means there are multiple charges, and we want to find the net force due to this multiple charges on, let us say, some given test charge. So again, using the superposition principle, of superposition, what is principle of superposition? Principle of superposition means that by vector addition, whatever we have explained just now, this is basically called as principle of superposition, where by using the vectors we try to calculate the resultant, final resultant of all the vectors. So here also we will use the same principle. The force on, let us say, there is a charge Q1 and there are multiple charges in the surrounding Q2, Q3, Q4. There are multiple charges. Last one is Qn. So this n can be anything. It can be 50, it can be 100. There are multiple charges. So what will be the net force on Q1? Net force. You can write here net force on Q1. On Q1 will be equal to force on 1 due to charge 2 plus force on charge 1 due to charge 3, force on charge 1 due to charge 4, and finally force on charge 1 due to nth charge, last charge. So the net force on charge Q1 due to multiple charges Q2, Q3, Q4, Qn will be given by F12 is K Q1 multiplied by Q2 divided by R12 square. R12 is the vector towards 1 from 2. Similarly, F13 is Q1 multiplied by Q3 R13 square, and last one will be K Q1 Qn R1n square. So we can write it as K will be we can take outside because it is common to all terms, and Q1 is also common to all terms. Use summation sign. I start from 2 till n. This will be Qi upon R1n square. So this is the net force on charge Q1. So try to by heart this formula for net force on charge 1 due to multiple charges. That's all for today's lecture. If you liked the video, then please follow and subscribe the channel for more videos. Thank you.